Alright. Let's turn that down. So, for the first problem I decided to put in this video was problem number 7. I was going to say letter 7, excuse me. And this is where we integrated by parts. And up here, let me switch this over here. We integrated by parts. Over here we have the integral of f times dg equals fg minus integral g df. And this one was really simple because it was the integral of s times e to the power of s divided by 2 ds. And then f equals s right here. And dg equals e to the power of s divided by 2. And df equals ds, which is the derivative. And g equal, or the antiderivative. Derivative, sorry. Ignore me. G equals 2 times e to the power of s divided by 2. And it was really simple because we get to 2 times e to the power of s divided by 2 times s minus 2. And it's really simple just because, and then we have this, and we really just get rid of this, that's why it's like bold. And we get, mainly this right here is our answer already, but because we have to multiply this times this times this, we get, it would be just 2e to the power of s divided by 2 times s minus 2, but I went ahead and just distributed, and we get e times s divided by 2 times 2s minus 4 plus c, because we don't have a specific starting point. And the second one I decided to use was problem 1 for the integration by substitution. Now, back home, I learned how to do substitution like this, very simple, where you have the integral of u to the power of n times u prime dx equals u to the power of n plus 1 over n plus 1 plus c, which is very similar to just like reversing the chain rule. And for this problem, we had the integral of -1 to 0. And then it was x cubed over the square root of 16x to the power of 4 plus 9. And I simplified it to equals x cubed over 16x to the power of 4 plus 9 to the power, both of these, to the power of 1/2, which equals x cubed times 16x to the power of 4 plus 9 to -1/2 because we brought it up from the bottom of the denominator. Wait, we brought it up from the denominator, and that makes it a negative. So u equals whatever's in the parentheses is 16x to the power of 4 plus 9, and then u prime equals 64x cubed. And then doing the simple part right here, we just do x cubed. Sorry, this doesn't go right here. We just do x cubed over u prime, which is 64x cubed, and we get equals 1 over 64. And then we multiply that right here times 16x to the power of 4 plus 9 to 1/2, because we have 1/2 now because it's n plus 1. That would be -1/2 plus 2 over 2, and then -1 plus 2 equals 1, and we get 1/2. Over, it would be 1, I would have put the fraction 1 divided by 1 over 2, but it would have been really complicating, so we just put 0.5. And so 64 times 0.5 is 32, and then 1 times this is the same thing, and we get, the function is f of x equals 16, in parentheses, 16x to the power of 4 plus 9 to the power of 1/2 over 32. And then we plugged in 0 and got 0.09375, plugged in -1 and got 0.15625. Now, because the fundamental theorem of calculus is f of b minus f of a equals the answer we got here. I forgot what it's called for a second. And so we got, that's why we had to put a minus. And we got equals -0.0625. And then the last one was problem number 3, and I also did the fundamental theorem of calculus, which is right here. And it's the integral of 0 to 3 of 4, we're just going to move that out of the way, 4t squared minus 3t plus 1 over 3, in parentheses. So f of x just equals 4t times 4t, and this also, let me go back, this is also the same as right here, just different letters. and we get 4t, this would be n plus 1, which is 2, is 3, and then we just divide it by this, and then minus 3t squared over 2 plus 1 over 3t plus c. But I just put that in red because we don't really need it since we have what we're using. And so 4t cubed over 3 minus 3t squared over 2 plus 1 over 3 times t equals the function f of x, capital, which is the antiderivative. And then f of b equals 23.5 and f of a equals 0. So 23.5 minus 0 equals 23.5. And this is our final answer. With that, we did it. Thank you.